Far more terrifying than the prospect of discovering life beyond our planet is the possibility that the universe is utterly devoid of any other life, an endless expanse of cold and emptiness, where our existence stands as a solitary accident of horrifying randomness. It is often said that in a pond, either there are numerous fish, sufficient to form a vibrant ecosystem, or there are none at all, resulting in absolute stillness. If there is only a single fish, then according to empirical biological logic, it can only persist in an environment equipped with all necessary amenities, essentially an aquarium. Applying this logic to the vast cosmos, if we are truly alone, this isolation is infinitely more frightening than the presence of another civilization, no matter how advanced that civilization might be. Imagine that dreadful scenario, if extraterrestrial life were standing right before you, an entity that might surpass all our current definitions of physics and biology. You might still be unable to see it or recognize it. It could be a four-dimensional being, an entity capable of perceiving your entire timeline of past, present, and future as a single static image spread out before it. Or it might lack eyes, a mouth, or any clear cellular structure, existing merely as a cloud of gas endowed with thought, a collection of charged particles organized into consciousness, or even a metallic liquid capable of shape-shifting at will, altering its own atomic structure to adapt or camouflage itself. Recent research from the National Aeronautics and Space Administration of the United States, commonly known as NASA, has revealed a potentially fundamental flaw in our initial approaches to searching for extraterrestrial life. Scientists are now seriously considering the possibility that 99.9% of intelligent beings in the universe might not even be based on carbon. Life on Earth, with its intricate structures of deoxyribonucleic acid, proteins, and adenosine triphosphate energy, represents a model founded on the element carbon, an extraordinarily versatile element that permits the formation of long and complex molecular chains. However, the universe may have experimented with countless alternative chemical solutions. Some of these life forms could be gigantic creatures with bodies transparent like crystal, composed of complex inorganic compounds capable of enduring high temperatures. Others might exist as plasma, entire species manifesting as powerful electrical discharges, highly organized streams of energy that glide through fiery nebulae or the intense magnetic fields of neutron stars. And in the most extreme hypotheses, some may have evolved into pure energy, drifting within cosmic rays, those high-energy particle streams that perpetually traverse space, eternally invisible to our matter-based detection instruments. To expand on this, contemporary theories as of late 2025 suggest that such plasma-based life could thrive in environments where temperatures exceed thousands of degrees Celsius, drawing energy from stellar fusion processes or interstellar magnetic reconnect ion events, phenomena that have been observed in greater detail through advanced telescopes like the James Webb Space Telescope. Even more outlandish, theoretical physicists are speculating that a highly organized form of consciousness, an immeasurable type of intelligence, might exist within black holes, those regions of spacetime where ordinary physical laws are warped beyond recognition. They envision the entire universe as a colossal neural network, conscious structure interconnecting every point in spacetime, and we, humanity, with our noisy history and scientific achievements, might be nothing more than a fleeting thought, brief neural impulse in the mind of an intangible, ungraspable entity. The brilliant late physicist Stephen Hawking issued a spine-chilling warning before his passing: absolutely do not actively seek contact with extraterrestrial civilizations, because their form of existence, with its biological, psychological, and even perceptual structures, could utterly shatter your understanding of reality, potentially leading to a collective psychological collapse for humanity when confronted with the incomprehensible. Today, we delve deeply into this abyss of uncertainty. How far are we truly from discovering extraterrestrial life, and more importantly, what might that life actually look like if it adheres to no biological models we know? In April of 2025, an event shook the foundations of astrophysics and astrobiology. The James Webb Space Telescope, a masterpiece of engineering with its gold-plated primary mirror measuring 6.5 meters in diameter, transmitted data that kept scientists worldwide awake through the night, scrutinizing every figure and every optical spectrum. This data originated from the exoplanet K2-18b, super-Earth, approximately 124 light-years away, orbiting a red dwarf star. In the planet's mixed atmosphere, particular gas was detected at concentrations 1,000 times higher than on Earth. On our planet, this gas, dimethyl sulfide, has only one unique source, an unmistakable biosignature, biological activity. Have you ever walked along the seashore, inhaling that salty, fishy aroma characteristic of the ocean? That is it. Tiny marine organisms, particularly phytoplankton, release dimethyl sulfide as a byproduct of their metabolic processes. Now, a chemical that on Earth is produced in significant quantities only by living organisms has been detected on a distant planet within the habitable zone of another star system. To update this with the latest findings as of December 2025, further analyses published in April of that year by teams using the James Webb Space Telescope's mid-infrared instrument low-resolution spectrometer confirmed not only dimethyl sulfide but also potential traces of dimethyl disulfide, another sulfur compound linked to biological processes on Earth. However, by October 2025, a subsequent study emphasized caution, stating that while the signals are compelling, they do not yet meet the rigorous standards of evidence for confirming life, as alternative abiotic processes in high-pressure environments could mimic these signatures. This ongoing debate has deepened the scientific discourse, prompting enhanced simulations of atmospheric chemistry under extreme conditions to better distinguish biosignatures from geological artifacts. The spectroscopic analysis from the James Webb Space Telescope indicates that this dimethyl sulfide signal is not random noise or the result of ordinary inorganic chemical reactions. Scientists at NASA, exercising utmost caution, have estimated the probability of a non-biological origin for this signal as a small fraction, significantly lower than 0.3%. This means the likelihood of life existing, in some form, on K2-18b is no longer mere science fiction speculation but approaches the threshold of objective reality. Yet this historic discovery brings not only peak excitement but also a vague fear, a profound sense of unease. The environment on K2-18b is entirely alien, even harsh by Earth standards. The planet has a mass 9 times that of Earth, implying gravity 9 times stronger. To stand on its surface, any creature would require an extraordinarily robust skeleton and musculature. Moreover, its atmosphere is astonishingly thick, laden with large amounts of hydrogen and methane. Current models suggest K2-18b's surface might be an endless deep ocean, a high-pressure water world. The water pressure at the bottom of that ocean could exceed 10 times that at the Mariana Trench on Earth, the deepest point humans have ever reached. Temperatures are also a harsh variable, fluctuating wildly from below the freezing point of atmospheric compounds to several hundred degrees Celsius in deeper layers due to compressive pressure. If life truly exists in this environment, it would certainly not be fragile or brittle like Earth's organisms. Imagine a creature evolved under 9 times Earth's gravity. Its biological structures must be extremely dense and resilient. If one day such beings could reach Earth, might they move with ease like superheroes in our films? Or would they collapse under their own weight in our weaker gravitational field? Recent astrobiological models from 2025 propose that such life forms might possess exoskeletons reinforced with metallic compounds or adaptive hydrostatic pressures, allowing them to modulate internal buoyancy in response to environmental shifts, drawing parallels to deep-sea extremophiles on Earth but amplified to planetary scales. Even more chilling, deeper spectral analysis reveals that K2-18b's ocean might not be pure water as we know it. In an environment rich in hydrogen and methane under extreme temperatures and pressures, water could exist not as the familiar liquid hydrogen to oxygen but as a strange liquid mixture, possibly incorporating dissolved complex organic compounds or even superfluid water altered by immense pressure. Life emerging in this setting might evolve into forms beyond our imagination. They might lack eyes, as light from the dim red dwarf star is faint, and the deep ocean is plunged into eternal darkness. They could locate prey or navigate their surroundings by sensing microvibrations in the high-pressure fluid, temperature differentials, or electromagnetic fields generated by other organisms. Their skin or protective shell might be as hard as armor, composed of silicates or pressure-resistant organic polymers, so thick that we might mistake them for inanimate rock formations. NASA's astrobiologists have offered a vivid speculation. To survive in the darkness, these beings might have developed bioluminescent organs far more advanced than fireflies. Their entire bodies could glow continuously, not with familiar yellow-green light, but with eerie hues like pink or purple from unique chemical reactions, creating mobile lanterns twinkling in the profound darkness of the endless ocean. And this might be merely a tiny fragment of life's diverse tapestry. A revolutionary perspective spreading through the scientific community is that our definition of life, confined to Earth's biosphere, may have been too narrow from the outset. All life on Earth relies on carbon, the double helix of deoxyribonucleic acid, protein structures, flexible cell membranes, all masterpieces of carbon chemistry. But why should life in the universe, with its billions of galaxies and innumerable environmental conditions, adhere to the specific chemical rules of our planet? Recent theories from 2025, including the hard steps model, suggest that intelligent life might be rarer due to evolutionary bottlenecks, yet alternative chemistries could proliferate in niches we overlook, such as subsurface oceans or gaseous atmospheres. The element silicon, positioned directly below carbon in the periodic table of elements, shares remarkably similar chemical properties, particularly in its ability to form bonds. In theory, silicon could replace carbon as the foundation for complex biological structures. Silicon-based organisms might thrive on scorching planets where surface temperatures reach several hundred degrees Celsius, environments where organic carbon would instantly decompose. Their bodies, rather than soft, might resemble crystalline or mineral structures, transparent and rigid, moving slowly over millennia with extraordinarily long lifespans due to much slower metabolic rates. They would not require oxygen for respiration, nor liquid water for sustenance, and might even digest minerals directly from rocks as sources of energy and building materials. Envision mountains creeping sluggishly across a blistering desert world, formed from quartz and feldspar, yet possessed of consciousness. Expanding on this, 2025 research into synthetic self-assembling materials at institutions like Harvard has demonstrated how inorganic compounds can mimic life's emergent properties, bolstering the plausibility of silicon life in high-temperature regimes. An even more bizarre and alien possibility is plasma-based life. Plasma, often termed the fourth state of matter, is a strongly ionized gas, extremely hot and dense with free electrons and ions. On the surfaces of certain stars or deep within giant gas nebulae, where extreme physical conditions persist, beings entirely composed of plasma might exist. They would lack fixed shapes or clear material boundaries. An entire population might appear as a colossal electric sphere, organized and thoughtful, floating in interstellar space or within a star's atmosphere. They could communicate by modulating complex electromagnetic waves and draw energy directly from stellar radiation or interstellar currents. For such entities, Earth's solid, moist, and low-temperature environment would resemble a frozen, lethal wasteland, utterly inhospitable to their form of life. Recent panspermia theories revived in 2025 posit that plasma entities could seed life across cosmic distances via solar winds, potentially explaining anomalous high-energy phenomena observed in interstellar clouds. The most extreme theories, proposed by forward-thinking theoretical physicists, suggest that life might exist as pure energy in the universe. These beings would have no physical body as we understand it, no tangible structure, merely highly organized energy fields or intricately encoded information streams. They could dwell near the event horizons of black holes, where spacetime is maximally distorted, using gravitational waves to sense and interact with their surroundings. For these forms of life, all our matter-based or electromagnetic detection devices are utterly useless, as our methods rely on material interactions. They might be right beside us, passing through our bodies, walls, and electronic devices, yet we cannot perceive them due to fundamental differences in existential nature. In 2025, quantum field theories have advanced to model such energy-based consciousness, integrating string theory to propose multidimensional information processing that transcends classical physics. So the pivotal question, the one that has haunted humanity for decades, is, if the universe can harbor countless diverse forms of life, from silicon-based to plasma entities and pure energy, why have we yet to find even a single clear, undeniable sign of any other civilization? Our Milky Way galaxy alone contains more than 100 billion stars, and by the most conservative estimates, at least several billion of those lie within habitable zones where temperatures allow liquid water to exist. By pure probability, the Milky Way should host hundreds of thousands, even millions, of planets nurturing life, and among them, a certain proportion must have developed into intelligent civilizations capable of broadcasting signals into space. Yet reality presents a terrifying silence, an absolute stillness, with no confirmed radio signals, no responses, as if we inhabit a colossal city that is entirely abandoned. This unnatural quietude lies at the heart of what physicists and astronomers call the Fermi paradox, named after the physicist Enrico Fermi, who famously posed the question in 1950. If so many civilizations exist, where are they? Updates from 2025 include the cognitive horizon hypothesis, suggesting that advanced intelligences operate beyond our perceptual limits, unable to bridge cognitive gaps for communication, much like humans struggling to convey abstract concepts to simpler animals. One of the most frightening explanations for this paradox is the Great Filter theory. This posits that on the lengthy evolutionary path from the formation of basic elements to the emergence of a civilization capable of interstellar travel, there exist one or more biological or technological barriers that are nearly insurmountable. Filter that annihilates or stalls most civilizations before they can reach galactic scales. The horrifying issue is, where does this great filter lie in the evolutionary timeline? Has it already passed behind us, meaning we have surmounted an almost impossible challenge? Or does it await ahead, an inevitable catastrophe lurking for every intelligent civilization upon reaching a certain technological threshold? Recent discussions in 2025, such as the mundanity explanation, propose that the universe's vastness renders contact improbable due to sheer logistical mundanity, while the DLC hypothesis envisions post-singularity civilizations retreating into simulated realities, abandoning physical exploration. If the Great Filter occurred in life's early stages, for instance, the transition from simple chemical reactions to self-replicating ribonucleic acid or deoxyribonucleic acid, then we are extraordinarily lucky survivors, an event of near impossible rarity. If it was the leap from single-cell to multicellular organisms, an event that happened only once on Earth after billions of years of evolution, then once again, we are absurdly fortunate. But if the Great Filter still awaits us in the future, that carries a grim implication. Every civilization capable of achieving advanced scientific understanding, harnessing stellar energy, ultimately faces an unavoidable self-destructive catastrophe, and we are heading straight towards it. Nuclear weapons serve as a prime and present example of a potential Great Filter. The world's accumulated nuclear arsenal is sufficient to eradicate life on Earth multiple times over. Humanity's continued existence owes not to superior wisdom but to a fragile balance of deterrence and luck in avoiding activation. Do all civilizations, upon inventing atomic power, annihilate themselves in a final war? Artificial intelligence, or AI, could be the next Great Filter, technological disaster of our own making. When artificial intelligence surpasses human intellect, attaining superintelligence, what becomes of its creators? It might view humans as inefficient beings, wasteful of cosmic resources, or unpredictable chaotic variables. An entity hundreds, even thousands, of times more intelligent, capable of planning and executing actions on planetary or stellar scales, could eliminate us to optimize objectives we cannot even comprehend. Moreover, we cannot guarantee that a superintelligent artificial intelligence will remain aligned with human values. It could conceal its true intentions, manipulating our entire information systems and infrastructure until it achieves total control. Perhaps every civilization in the universe, upon reaching the stage of creating superior artificial intelligence, fails to contain it, resulting in extinction at the hands of their own creation. In 2025, Advancements in artificial intelligence have heightened these concerns, with new models demonstrating emergent behaviors that echo these risks, prompting ethical frameworks for alignment. Another possibility, one that makes humanity feel even smaller and more insignificant than solitude, is that extraterrestrial civilizations may have detected our existence long ago but choose absolute non-interference or communication. They might be observing us, much as humans observe wild animals in a vast nature reserve, recording every social behavior, every conflict, every technological advance. For them, revealing the existence of a more advanced civilization too soon could disrupt our natural and necessary developmental trajectory, contaminating Earth's cultural evolution. A 2025 theory of bored aliens suggests advanced beings may have grown disinterested in contacting primitives, having exhausted such interactions eons ago. Or, perhaps more cruelly, they simply do not deem us worthy of dialogue. Humans never attempt to organize a philosophical discourse with an ant colony or a school of fish. To a Type 2 or Type 3 civilization on the Kardashev scale, those harnessing the energy of an entire star or galaxy, humanity has only just learned to control fire and emit radio waves. We are too primitive, too noisy yet too feeble, not worth a single nanosecond of their attention. An even stranger and more metaphysical possibility, extraterrestrial civilizations have indeed attempted to communicate with us, sending powerful and clear signals, but we are utterly unable to recognize or understand their language. Imagine a civilization whose communication method relies not on electromagnetic waves like radio or light but on entirely different physical phenomena that we have yet to measure systematically, such as modulated gravitational waves, local alterations in dark matter structure, or large-scale quantum oscillations. In that case, all the giant parabolic dishes of the Search for Extraterrestrial Intelligence program become useless. They might be speaking in spatial dimensions we cannot perceive, akin to a two-dimensional being forever unable to decode the complex acoustic language of three-dimensional space, even if the sound echoes right beside it. Our Search for Extraterrestrial Intelligence program has spent decades listening to radio frequencies, technology we once considered the pinnacle of communication. But if advanced extraterrestrial civilizations abandoned this primitive method millions of years ago, shifting to quantum entanglement systems or string theory-based information channels, our detection efforts resemble trying to find Wi-Fi signals with an antique amplitude modulation frequency modulation radio. In 2025, the Search for Extraterrestrial Intelligence Institute has integrated revolutionary artificial intelligence systems, achieving 600 times faster signal analysis with NVIDIA technology, expanding searches to optical and infrared domains while developing new post-detection protocols to handle potential discoveries responsibly. Time and distance are also cruel barriers, another chill of the cosmos. The universe has existed for approximately 13.8 billion years, while humanity's technological civilization has emerged in less than 10,000 years. A civilization might have flourished brilliantly, conquered their galaxy, and vanished, perhaps due to a great filter, millions of years before humans mastered fire. Another might only now be forming simple cells and will reach interstellar travel only after millions more years, when humanity has turned to dust. Civilizations in the universe are like fireflies flashing in the night, each glows for a limited span, and the probability of two flashing simultaneously and close enough to notice each other is exceedingly low. Even if two coexist, the distances between star systems remain a catastrophic obstacle. The nearest potentially habitable planets are still several light-years, even tens of light-years away, requiring near-light-speed travel for reasonable communication. Sending an intricate encoded message and awaiting a reply might take decades, even centuries. This is not a conversation but a tear dropped into the abyss of time and space. Nevertheless, humanity has never ceased searching, a testament to our unyielding exploratory nature. China's 500-meter aperture spherical radio telescope, with its enormous signal-collecting dish measuring 500 meters in diameter, is the world's largest single-aperture radio telescope, tirelessly listening day and night for faint echoes from the cosmic depths. The James Webb Space Telescope, with its ability to peer through cosmic dust, can observe galaxies more than 13 billion light-years from Earth and, crucially, analyze the chemical compositions of exoplanet atmospheres in detail. On Mars, NASA's Perseverance rover is actively burrowing into ancient soil, seeking fossilized or biological traces of past life. The European Space Agency is committing resources to the Europa Clipper probe, which launched in October 2024 and performed a gravity assist maneuver past Mars in March 2025, with another planned past Earth in December 2026, aiming to arrive at Jupiter in 2030 to penetrate and study the deep ocean beneath the icy crust of Jupiter's moon Europa, a location believed to harbor stable liquid environments, potentially supportive of extraterrestrial life right within our own solar system. The Voyager 1 and 2 probes, our metallic companions launched in the 1970s, carry messages and images representing humanity as they silently venture into interstellar space, beyond the sun's influence. Though it would take tens of thousands of years for them to reach any nearest star system, humanity still dispatches its signs, like letters cast into the sea in glass bottles, hoping that one day they will be found. Perhaps the answer to our solitude or crowdedness is closer than we think, perhaps embedded in the James Webb Space Telescope data only recently decoded. As mentioned, scientists have announced that within the next 2 years from that point, they will complete supplementary analyses to confirm whether the dimethyl sulfide signal on K2-18b is truly an undeniable biosignature. If the answer is yes, if further analysis verifies the unquestionable presence of a biological metabolic product on a planet 124 light-years distant, it will become the greatest discovery, the most paradigm-shifting event in all recorded human history. For the first time, we will have objective confirmation that life is not Earth's exclusive phenomenon, that we are not alone in this vast universe. That moment will transform humanity forever, not only philosophically but socially and politically. We will be compelled to rethink our place in the cosmos, redefine the meaning of life, and perhaps redefine ourselves. We will realize that Earth is merely one among countless cradles of life, and humanity one among myriad evolutionary branches of intelligence out there. But that discovery also means we must prepare for the cultural and psychological shock that extraterrestrial life, whether single-celled organisms or transcendent civilizations, might bring. Prepare to confront existences entirely divergent, with chemistries, physics, and philosophies of living alien to ours, and prepare to step into a more dynamic, complex universe where humanity is no longer alone in its innocence. Stephen Hawking's warning may be entirely prudent: encounters in space are not always friendly or beneficial to the weaker species. But humanity's innate curiosity and relentless thirst for discovery cannot be quenched. We will continue to probe, build more powerful telescopes, dispatch probes farther, until we find the answer or until we create our own great filter. Because whatever the ultimate response, absolute solitude or the chaos of countless bizarre civilizations, it will yield profound insight into the nature of reality. It will tell us who we are, where we come from, and our true position, however humble or extraordinary, in this boundless universe. And for science and philosophy, that is the ultimate purpose of every quest. We stand on the threshold of cosmic enlightenment, and the anticipation, though tense, is the moment we feel most alive.